Okay, a train is traveling down a straight track at 20 meters per second. So do your diagram, show all the given information. So V initial is positive 20 meter per second. Now one thing I noticed right here, it says, so the engineer applies the brakes, resulting in an acceleration of negative 1 meter per second squared. What is this negative all about here? Does that negative mean less than 0? No. What is the negative? It's the direction. So, our sign convention, it's just like math class. To the right is plus, to the left is minus. Okay? So this train starts with a positive velocity, positive meaning what? To the right, but the acceleration is negative, which means to the left. What the heck is that all about? How is it possible to be moving to the right but accelerating to the left? It is. What's this train doing? Slowing down. The train is slowing down. Whenever velocity and acceleration have opposite signs, that means that the object is slowing down. If velocity and acceleration have the same sign, the object is speeding up. Okay, so this train has an acceleration of negative 1 meter per second squared. How far does the train move during a 40-second time interval starting at the instant the brakes are applied? Oh, you know what, guys? Hey, I'm just going to be honest here so you don't think that I'm like super duper smart. I remember this problem from previous years. Look at this 40-second time interval is misleading. Because why? The train is going to be stopped in less than 40 seconds. This 40-second time interval is just being straight up tricky. What they want us to do is figure out how far the train travels. Let's read again. How far does the train move during a 40-second time interval? So, the train is going to reach a point where the velocity is 0, right? V final is 0. How long does it take for the train to stop? If you understand acceleration, what does negative 1 meter per second squared mean? It means 1 meter per second every second. What's the starting velocity of the train? 20. So how long is it going to take the train to be stopped? 20 seconds. And I'll just let me show you what I just said with an equation. You could calculate the time it takes for the train to stop with this equation. Vf equals V initial plus AT. V final is 0. The train's going to stop. So T is going to be negative V initial over A. So that's negative 20 divided by negative 1, which gives 20 seconds. So look, this 40-second right here, what's the problem doing? Being tricky. The problem's being tricky. It's messing with your brain. So that's irrelevant because when will the train be stopped? In 20 seconds. So what we're doing is we're solving for how far the train travels from start point to end point. So do we have enough information to do that? Yes, we're looking for this displacement. So the equation that does it is Vf squared equals V initial squared plus 2ax. V final is 0. So x will be negative V initial squared over 2a. So that's going to be negative 20 over 2 times negative 1, which is going to be 400 over 2. So that's going to be 200 meters. Is that the answer? Yeah. That's a mean problem, huh? That's mean. The 40 second here, they're playing with they're messing with you.